Oh, it's math. It's math. Math with Sci. Math. It's math. Math with Sci. Okay, so hello. Little bit strange. I realized that when I do screen recordings on my laptop, it does not actually doesn't actually record the audio. So we are going to start again. And we were talking about solving for linear equation given 2 points. And so I guess in general we've been talking about linear equations, and it's important to note, I think, that 2 points will give us a unique equation. We can talk about why kind of in a later video. Unique and I don't know. I think this is how it goes. Unique. Line. So we want to kind of create the equation that describes this unique line. And unique is kind of an interesting word in math, just because it means that it gives this line, but only this line. So that's kind of interesting. And so I was going to, we're going to break this up kind of into 3 different ways. We're going to think about it just algebraically first. And then we are going to kind of take a tabular method. And then we're going to go about it graphically. And so this is going to be part 1, part 2, and part 3. I'm going to upload them kind of in that order. But algebraically, I think is going to be kind of interesting, just because I want to go, when we talk about this, we're going to talk about kind of like the concepts, maybe. So we're going to keep it all in variables on one side. And so we're going to talk about kind of what's in front of us. What does that mean? We're going to go really slow and kind of try and be thoughtful here. And then over here, we're going to have a numbers example. And I think it might help explain the variables. Because if you're trying to train your brain to think in the language of math, which is why I think it's kind of hard, it is an entirely different language. It's a universal language that's like agreed upon amongst humans, but it is different. It totally takes the observer out, which is weird to think about. So we're going to start with variables. And so we are going to, this would be kind of our question. So we are going to say, find, the line that contains points x1, y1, and x2, y2. And so over here, if we put that to numbers, contains, I guess we should say the points. It's a little bit better. And over here we're going to go 1, 3, and then 4, 9. And so, this is kind of hard. So first we have to look at 2 points, and then our end goal is we want to be able to create a line in, we're going to pick this form, slope-intercept. It doesn't have to be this one, but I think this one shows us a lot of cool stuff. And if we learn this one, it'll be easier to translate this into the other form. Yeah, I agree with that. It'd be really easy to put this into a standard form, or, once we have this kind of thinking, we can do point slope. And so, again, we have an end goal of y equals mx plus b. Over here, we're going to have that m is some number and b is some number. And then over here, we want expressions for m and b, we can do m, b, x1, y1, x2, and y2. So whenever we're doing the expression for m, it'll be like m equals, and we can use these variables. When we do the expression for b, we can use m, and then this kind of group, our points. And so we'll see what that looks like if it's a bit confusing at first. But first we kind of have to think about, well, what does it mean? So what are slope and y-intercept? That's what these are, where your m is your slope, and then b is our y-intercept. And so we have points and we kind of want to get there. So let's think about what do 2 points give us? What can we kind of talk about? So the 2 points, what can we do with that? We can first talk about their locations. Some of them might have interesting locations. This might be interesting. We know that y is equal to b when x is equal to 0. So maybe if we know that either y1 or x1 is equal to 0, we can find something about the y-intercept. Either y1 or y2 or y1 will then be that y-intercept. This is terrible. Location. We could talk about maybe the distance between the points. And this is going to be the interesting part. And we can look independently. We could try and find how long that line is between. That's not really going to be too interesting here. It's because we're not really talking about distances. We kind of want, what is true for all x and y points is going to be the slope and then this y-intercept. And so we want the distance between 2 points, namely distance between y, or the change in y, and the change in x. So do we go up? Do we go down? What's going on? So over here, we can kind of look, and we've got this is x1, y1, x2, y2. So let's kind of apply this. So first off, none of the x's are 0. So 9 and 3, we know those are, it's not going to be our, it's not going to be our y-intercept because it is not a constant function. So it's not, i.e., y equals 3 or y equals 9, because we know that that's not true at either this point or this point. This is kind of information we can gather. Another thing is we can look at the distance between the 2 y points, and we can call that y2 minus y1, and that's going to be 9 minus 3, which is 6. And then the distance between the x points x2 minus x1, which is 4 minus 1, 3. And then we can use, this is by definitions. I'm going to try to make another video annotating my definitions paper. Maybe that will help. Ooh, sorry. But here we go. So we have slope, which is our m, is equal to the change in y over the change in x. So this is kind of how we get from this, the distance between the points. That might tell you about slope. You might have to use your formulas or your definitions. But either way, that's kind of how we get there. And so can kind of fill this in. And here we know that m is equal to 2. And so what kind of happened? If we're looking at it from just a variable sense. So over here we had delta y was defined, y2 minus y1. And delta x is x2 minus x1. And then the slope, we can define that as y2 minus y1 over x2 minus x1. And then this is what we mean by an expression for m in terms of these guys. So we've got, y1s, x1s. These are all going to be numbers, and we can, it'll equal some number. That's the big point. So in this specific case, the number was 2, but in general, we want some number, and this is how we get there. And we can kind of see over here, we had this was equal to y2 minus y1 over x2 minus x1. And so now I'm going to, we'll rewrite what we've got going on. So we have y equals 2x plus b. We still don't know about b. This is our question mark guy. Next step. And then we have y equals, I'm going to keep it mx plus b just because m is a lot easier to work with than this craziness. But we know that all this craziness is a number. So just imagine m is some number now, and we know how to find it. Now what we have to think about is, how do we get b? Well, we know that this statement here, y equals mx plus b, it's true for every single point. So it's true for all, which sometimes is written like this, for all points on the line. So that means it's also true that y1 equals m times x1 plus b, and that y2 equals m times x2 plus b. And so we can kind of go over here. Let's rewrite point 1 and point 2. Then we can see that 1 has to be equal to 2 times, goodness gracious. 3 equals 2 times 1 plus b. And so I guess before we kind of do this, why is this important? So since m is a number now, just some number, we have number, number, and number. So b is, we can figure out, we can isolate b and find an equation for it. I guess we can actually do that down here. y2 minus m times x2 is going to be equal to b. And we'll see over here kind of how that works out. So here we have this equation. And then we'll see what it looks like if we use this other point. Because both points are usable. You can use any point you wanted to. We'll write it in the same order. I think that's important. To do 2 times 4 plus b. So then we have 3 equals 2 plus b. 9 equals 8 plus b. We can, move this 8 over by subtracting from both sides. We see 1 is equal to b. By the same, we can group these numbers together by subtracting on both sides. And then we see, again, 1 is equal to b. Or, y minus m times its corresponding x point will be equal to b. And so then we have, finally, y equals 2x plus 1. And then this is kind of how we would define it in variables. I would write the most simple form where m is equal to y2 minus y1. And then b is equal to, we got y2 minus mx2. And so here we have it, this is true, and there it is. If you wanted to put the numbers, or if you wanted to fill everything in and actually plug this in here and put this in here, you most assuredly can. It looks a tiny bit messy, but it's not terrible, honestly, and I'm pretty sure we'll see what it looks like. Actually, we'll do that in a different one. But yeah, so this is the end of our algebraic exploration, and so this is the line that will sum it up in a good statement. So this contains 1, 3, and 4, 9, and vice versa. This is the line that contains any 2 points. x1, y1, x2, y2. It's important to kind of define what those look like. So, yeah, there we go. Hope you guys like it. Let me know if you have any comments, if you want me to elaborate on anything, any criticism that you think, would be useful and it would help you understand a bit better. But I hope you guys have a great rest of your night.